This looks like a perfectly flat train wheel. If you place it on a railroad track and give it a gentle push, it rolls just fine. But railroad tracks aren't always straight. The moment the train enters a curve, a flat wheel can easily derail. Here's why. On a curve, the outside rail is longer than the inside rail. That means the outside wheel has to travel a greater distance. But if both wheels are spinning at exactly the same speed, they can't cover different distances, and the train could leave the tracks. So engineers came up with a clever solution. Instead of making the wheel completely flat, they gave its tread a slight cone shape. Now, when the train moves through a curve, the wheel set naturally shifts slightly to one side. The outside wheel rides on the larger diameter part of the cone, while the inside wheel rides on the smaller diameter part. Even though both wheels rotate together at the same speed, the larger diameter covers more distance with every revolution, while the smaller diameter covers less. That perfectly matches the different lengths of the two rails, allowing the train to glide smoothly through the curve without slipping. But even this design has its limits. If the train is moving too fast, or the curve is extremely sharp, the wheels can shift too far. That's why every train wheel has a raised inner rim called a flange. Most of the time, the flange never touches the rail, but if the wheel moves too far sideways, the flange contacts the inside of the rail and helps guide the wheel back into position, preventing a derailment. The flange has another important job. When a train needs to switch from one track to another, special movable rails, called switch points, guide the flange onto the new track. That's how trains change tracks safely and smoothly. And just like that, you've discovered the brilliant engineering behind the modern train wheel.